Hello students, welcome to the video on the field effect transistors. This is module 4 of the 18EC33 electronic devices subject. So in this video, we will be discussing about what is meant by field effect transistors and what is meant by characteristics equivalent circuit and the frequency limitation of the JFET MOSFET. What is a two-terminal MOS structure, its energy band diagram, the capacitance voltage characteristics and frequency effects. Also, we will be learning what the basic MOSFET operation and its current voltage characteristics. Coming to the JFET, there are different types of the types of field effect transistors are like we have a JFET as well as MOSFET. JFET is nothing but junction field effect transistor. Again, it has two types. One is N-channel JFET and the other one is P-channel JFET. Similarly, the metal oxide field effect transistors, metal oxide semiconductor field effect transistor, otherwise it is called as insulated gate field effect transistor. It is of two type. One is enhancement mode and in depletion mode. In enhancement mode, again we have N-channel E-MOSFET as well as P-channel E-MOSFET. Similarly, the depletion mode also consists of N-channel DMOSFET and P-channel DMOSFET. So, what is FET? FET is a voltage control device. It is field effect transistors. So, compared to the BJT, which we have studied in the previous module, the BJT is it's a bipolar device in the sense that the current will be due to both electrons as well as holes. Here, FET is an unipolar device, or I can say that it is there is only one current flow will be either due to electrons or hole in a device. And here, the carriers in the BJT are the charge carriers. Mainly, it is due to the diffusion process. That is, the current is mainly due to the diffusion current. But here, the JFET operates in the reverse biased mode always, and hence their current is by the drift process. In BJT, it has a lower switching speed because of the diffusion speed and diffusion process. Whereas FET here, the current is movement is due to the drift, so the switching speed will be very high. The BJT is not a thermally stable device, whereas FET has a negative temperature coefficient and high current operation. That is, the current decreases as temperature increases. Due to this particular feature, a uniform temperature distribution and protection against breakdown can be achieved. In the case of BJT, it requires more space compared to the FET. Also, as it offers less power gain when compared to the FET at audio frequency. The BJT is a current control device, that is, the output current is controlled by the input current IB. Here, the FET is a voltage controlled device. BJT will be working with the emitter to base junction as forward biased, hence the input impedance will be low, whereas FET operates with always gate reverse biased, so the input impedance is used it is very high. Therefore, it can be used as a buffer. And also, BJT is much noisier than FET and it has an offset voltage. And BJT can be used as a switch. It will be taken to the off state when operating in the cutoff region and to the on state when it is operating in the saturation region. Whereas FET is useful for its operation as a controlled switch operating in both the conducting and in the non-conducting zones. So this is the comparison between the FET and the BJT. Now coming to the JFET structure, the JFET consists of three terminals. One is source, gate and drain. The JFET can be either P channel or N channel. So the arrow at the gate points the in it indicates the direction of the current flow. So it is in for the N channel and out for the P channel. So coming to this diagram, we can see that here the first one is the P channel JFET. Here the main substrate is going to be the P, and we will be having heavily doped N layer on both sides, and hence because of that the channel formed is a P channel, and in the N channel the basic substrate is N, and we will be having a channel of N type. So the next diagram is a symbolic representation of the N channel and the P channel JFET. So here we can see that the arrow when it goes inside the gate, it indicates an N channel, and the arrow which is coming outside, it indicates the P channel JFET. So this is the symbolic representation of a JFET. So construction of the JFET, it is a three-terminal device whose one terminal is capable of controlling the current between the other two. So the gate is the controlling terminal here, and the current flow will be between the source and the drain. So the width of the junction is used to control the effective cross-sectional area of the channel that conducts the current. So the gap between the two depletion region will be the channel, and it is the path through which the current will be flowing. So in this case, if the depletion region increases, obviously the channel width changes, and hence the resistance to the current also increases. So based on the type of the material used or type of the semiconductor material used, it can be the JFET can be used as either it has two types, namely N channel and the P channel. So here in this diagram, here we have an in this diagram, we can see the N-channel JFET. Here, the substrate is an N-type, and then some heavily doped P-type is done at the two side of the substrate, and they both are interconnected, and it is named as the gate terminal. One end of the material N material is taken as a source, and other end is taken as a drain. So the source and the drain are interchangeable. Here, coming to the operation of the JFET, we can say that here you will be supplying two supply, that is one is to the gate terminal and another one is to the drain terminal. Normally the gate will be always reverse biased. Since here gate is P, I am connecting the negative terminal here with respect to the source, and here the drain will be more positive when compared to the source, and hence this will be plus, and the supply voltage will be plus minus for the drain VDD. So VDD provide a drain to source voltage and supplies current from the drain to source, and VGG sets the reverse bias voltage between the gate and the source. So this VGG which is applied, the VGG which is applied here will supply a voltage across the reverse biased diode, and that voltage is called as the VGS. And also the drain to source current ID will be decided by the voltage VDD. JFET is always operated with the gate to go source PN junction reverse biased. The gate to source junction never allowed to become forward bias because the gate material is not designed to handle any significant amount of current. So that may lead to it may result in the destroying the component. So here in this video we have discussed what is meant by JFET. So as a recap, I can say here the JFET consists of three terminal. One is a gate, drain and source. Also we will be having always two supply voltage. One is to reverse bias the gate terminal, and another one is to supply the drain current. Always the drain current will be always from the source to the drain. So again the drain and source are interchangeable. So those terminals can be interchanged. The reverse bias at this junction or this gate junction always makes the FET to be at high input impedance, and also the reverse bias will result in the current mainly due to the drift process. So the change in the gate voltage will change the depletion region of this device, and hence the change in the depletion region will result in the it will result in the change in the channel width. So the channel width is nothing but which controls the amount of current flowing through the device. So here the output current what is flowing the device, that is the output current which is flowing from my source to the drain and through the terminal drain terminal ID is decided by the applied gate voltage, and hence it is called as an voltage control device, and the electric field developed is will affect the operation of the transistor, hence it is called as the field effect transistor. So we will be discussing about what is the VI characteristics of this JFET in the next video. Thank you.